All right, let's pull back the curtain on a magic trick your computer performs every single second. We're talking about how it seems to do a million things at once, when its brain can really only focus on one. It's a fantastic illusion, and in this explainer, we're going to show you exactly how the trick is done.
Just think about what you're doing right now. You've got this playing, maybe a browser with a bunch of tabs, music in the background, a chat app pinging. But here's the crazy part. Your computer's processor, its actual brain, can only do one single thing at a time. So how does that work? Well, the secret is your computer isn't a multitasking genius. Nope. It's a world-class magician, an incredible illusionist.
And the master magician pulling all the strings? It's this unsung hero we all use but barely think about. The operating system, or just the OS. It's the director, the stage manager, the ultimate juggler that creates this seamless illusion of multitasking.
So what exactly is an OS? Think of it as the foundational software that runs the whole show. It's like the air traffic controller for all your computer's resources, the CPU, the memory, even your mouse clicks. It's that super important middleman between the apps you use and the actual physical machine.
Okay, so to really get how the OS pulls this off, we need to start thinking like an OS. See, when you open your web browser or fire up a game, the OS doesn't see an app. It sees something much more specific. It sees a process.
And what's a process? It's basically a program in execution. It's the living, breathing instance of an app's code up and running. This is the thing the OS actually manages. So when we say multitasking, what's really happening is the OS is juggling dozens, sometimes hundreds, of these individual processes all at once.
So how on earth does it keep track of all of them? Well, it gives every single process its own little passport. Seriously. The technical name is a process control block, or PCB, and just like a passport, it holds all the vital information about that specific program while it's running.
And if you could open up this little passport, you'd find everything the OS needs to know. You've got its unique ID number, its current status, like is it running right now or is it waiting for something? And the most important part, something called the program counter. Think of this like a bookmark in a book. It tells the OS the exact line of code the program was on when it was interrupted. This little bookmark is the whole secret to how the OS can pause a process and then start it back up again perfectly without missing a beat.
All right, so we've got our processes, and each one has its passport, the PCB. Now we get to the real magic trick, the main event, the great CPU switcheroo.
So how does the OS actually do the juggling? How does it decide who gets the CPU and for how long? Well, it's all about managing the state of each process. It's like a master chess player constantly moving pieces around the board.
Let's start simple. At any given moment, a process is either running, meaning it's the one currently using the CPU, or it's, well, not running. The OS's whole job is to pick a process, let it run for a millisecond, then pause it and grab the next one.
But in reality, it's a bit more sophisticated than that. I mean, not running can mean a couple different things, right? A process that's just waiting for its turn is very different from a process that's stuck waiting for, say, a file to download. So the OS is smart about it. It keeps a list of processes that are ready to go, just waiting for the CPU. And it has another list for processes that are blocked because they're waiting on something else. The OS only ever picks the next contender from that ready list. Super efficient.
And this rapid-fire swapping, this action of pausing one process, saving its passport, and loading up another one, has a name. It's called a context switch. This is the core of the whole illusion. It happens so incredibly fast, we're talking hundreds or thousands of times a second, that our human brains can't possibly perceive the gaps. To us, it just looks like everything is running simultaneously.
So let's walk through it, lightning fast. 1. Something happens. Maybe the process's time slices up. Boom, the OS takes over. 2. It saves everything the current process was doing, its context, right into its PCB passport. 3. It changes that process's state from running to ready and puts it in the ready line. 4 and 5. The OS grabs the next process from the front of the ready line and loads its context from its passport into the CPU. And just like that, the new process is running. This whole dance happens over and over and over again.
Okay, but wait a minute. If the OS is just swapping all these programs in and out of the driver's seat, doesn't that sound kind of chaotic? Like, what's to stop one buggy app from just wrecking the whole system for everybody? Well, there are some very strict rules of the game. To keep everything safe and sound, the CPU itself actually has two different modes it can run in, two privilege levels. The best way to think about it is like a concert venue. You've got the general admission area, and then you've got the all-access VIP backstage area.
And this separation is absolutely crucial. All of your applications, your browser, your music player, your games, they all run in what's called user mode. That's the general admission section. They have limited privileges and absolutely cannot touch the hardware directly. The OS kernel, on the other hand, gets to run in kernel mode. This is the VIP backstage pass. It has full, unrestricted access to everything, which is how it manages and protects the whole system.
So you might be wondering, if an app can't touch the hardware, how does it do anything useful, like saving a file? It has to ask the OS for help. It makes a formal request called a system call. When that happens, the CPU flips into kernel mode, the OS does the heavy lifting, like writing to the disk, and then immediately flips back to user mode and hands control back to the app. It's basically like politely asking the bouncer to do something for you because you're not allowed in the VIP area. Now, it's really important to get this straight. This quick flip between user and kernel mode is called a mode switch. It's super fast, and it all happens within the same process. That is totally different from a process switch, the context switch we talked about earlier. That's the big one, where the OS saves an entire process's passport and loads a completely different one. Much more overhead involved there.
All right, there is one last giant piece of this puzzle. With all these processes being swapped around, how does the OS make sure they don't mess with each other's memory? How does it stop your browser from accidentally snooping on your password manager? The answer is, you guessed it, another brilliant illusion called virtual memory.
What virtual memory does is it gives every single process the illusion that it has the entire memory of the computer all to itself. It's like giving each one its own private mansion. In that mansion, it can do whatever it wants and can't see its neighbors. But in reality, all these processes are living in tiny separate apartments scattered throughout the same building, the physical RAM. They just don't know.
And the reason this whole scheme works so well is because of something called the principle of locality. Basically, programs tend to work on just a small set of data at any one time. It's like when you're cooking, you only need a few ingredients out on the counter, not the entire grocery store. The OS is smart. It keeps just the active ingredients in the super fast physical RAM and leaves the rest tucked away on the hard drive until it's needed.
Now, this incredible level of complexity didn't just pop up out of nowhere. It's been a long evolution. Back in the 50s, computers were simple, one job at a time. Then in the 60s and 70s, we started getting multi-programming and time-sharing, the baby steps of multitasking. But it was really the personal computer revolution in the 80s and beyond that forced the OS to become the master juggler that it is today.
And this really says it all, doesn't it? The OS is that invisible foundation. It's the master coordinator that makes literally everything else you do on your computer even possible. It's the software that makes all the other software work.
So we've gone from managing one simple job at a time to juggling billions of processes across global networks. The scale is just mind-boggling. Which leaves us with a big question for the future. In a world that's headed towards massive AI, quantum computing, and an Internet of Everything, what's the next great challenge? What's the next impossible illusion the operating system will have to learn to perform for us?